Hello. So I am here to discuss about crosstalk in communication channels. So what is crosstalk? Crosstalk arises in a time division multiplex system using amplitude modulation. When some of the energy proper to one channel arrives during the time allocated to the other channel. If the demodulating pulse is narrower than the transmitted pulse, then crosstalk attenuation may increase. So how can we improve crosstalk? We can improve it by using both coupling and decoupling networks simultaneously. We can also use rectangular pulse, which is advantageous when the number of networks in the transmission path which distort the pulse shape is small. But when the number is large, however, the improvement by using some other pulse can be worthwhile. And the last thing is we can avoid the phase error in demodulating carrier signal, which will be discussed in the following example. So this is basically problem 3.14, in which the demodulating carrier signal has a phase error of phi, which will cause the crosstalk to occur, and which will be proven mathematically in the upcoming slides. Let's analyze this question when phase error is 0. And here AC is the amplitude of the carrier signal which was used in multiplexing of the two signals M1T and M2T. The multiplexed signal is fed into the demodulating part of the demodulator, where the one part is multiplied with 2 cos 2 pi fct and the other part is multiplied with 2 sin 2 pi fct, and the resultant signal consists of one independent term consisting of only M1T or M2T, and other two terms have harmonics in the higher frequency, which can be easily filtered using the low pass filter. So at the end of one output we get AC into M2 M1T, and other end we get AC into M2T. So basically we have demodulated the signal perfectly. Only there is a scaling of signals by the factor of amplitude of the carrier signal. Let's analyze the case when phi is not equal to 0 or there is phase error in the demodulating carrier signal. Now our multiplex signal is fed into the demodulating system, where it gets multiplied by 2 cos 2 pi fct plus phi on one side and 2 sin 2 pi fct plus phi on the other side. Now the both sides the multiplied signals consists of 4 higher order harmonic terms of frequency double the frequency of the carrier signal, which will be filtered out by the low pass filter. But now the terms consist of cos phi and sin phi dependent terms, which will which will be equal to AC M1T cos phi plus AC M2T sin phi. Now when we have expected the output as only AC M1T, we get phi dependent terms on the both outputs, which is basically crosstalk. Because on the first side we got the output as AC M1T cos phi plus AC M2T sin phi. So basically the part of M2T or sin phi part of M2T is coming to the first signal, and sin phi part of M1T is going to the other signal. So total energy gets distributed between the two sides rather than going to the individual proper channels. So here the crosstalk occurs. Thank you.